Hello, everybody. My name's Steve Demeg. I'm a Python developer looking for some freelance gigs. So I've been doing a series of presentations based on for software development, and I'm doing a little app. I've been doing it in stages. It's a stock analyzer. So let's take a look at that. It's a stock analyzer. Basically, you give it a common name like Tesla or Pepsi or Apple, and it's going to go off and it's going to find some information about the stock for you. So it's going to find the ticker symbol, the current price. It's going to get a description of it from ChatGTP. It's going to give you historical data of what the stock price has been doing over time from Polygon. And then it's going to find sentiment of comments of videos and posts from social media. So we're using, in this example, we're using YouTube and Reddit. The big reason for those is because they have a easier API to use than some others. Just as far as getting getting a key and all that kind of stuff, it's just a little bit easier. So I didn't want to go into too much depth on having to do stuff like that, jumping through hoops to get a key or a API key. So I use those two. Basically, is how it is. All of this data over here is none of it comes local. It's all stuff that we've grabbed from the web. So that's kind of how it works. We'll see. We'll get an example, so don't worry about that. Architectural wise, it's got a front end that's written in JavaScript using Vue. It's got a back end that uses Fast API. It uses Beautiful Soup to, when we do some web scraping, we could get that back and use an HTML parser to parse out some data. Uses Bonobo to multi-thread our pipelines for gathering these things. So like each one of these pictures over here ends up being translated into a DAG that gets executed in parallel. We grab all the pieces in parallel, and then we put it all together and return it to the UI. So that's how that works. Requests library. So there's at least one instance in there where we don't use automation to get the data. We use just a direct REST call, and then for that we use requests. Natural language toolkit. So we analyze the sentiment of comments using that, and I'll go into more detail later on that. And Playwright is a automation tool from Microsoft. It's like Selenium Lite, kind of. It allows you to automate clicks, entering data into like a search box, different things like that. Automate those through a Python program. It's a very powerful. I like it a lot. And then it all runs on top of Python. So Python's the main language. Basically what we do is we implement all these endpoints over here using Fast API, and then this code in here scrapes these different websites for data that we end up using in the application. So we'll see how that works as well. Let's go through this. Talk about Fast API. What is it? It's a web framework for building APIs and endpoints. It's it's got a lot of good features. I like it. One good feature I really like is that I like the Pydantic, which I like strongly typed stuff, and I like that it's tied to Swagger so that you can easily generate documentation from it by just your the strings you use in there to define the methods. So doc strings. So it's really nice, and I like it. It's lighter weight. It's lightweight. There's a couple other frameworks out there, Django. It's a little heavier weight, I would say, for sure. And Flask. Flask is excellent as well. I like Flask. If you don't want to mess with having to, have a web server as well, just all in one, Flask is great. So I like either Fast API or Flask are my two favorite, for sure. But I'll use Django as well. Django's pretty nice as well. I don't mind it. Web scraping for parsing HTML data we might get back from a website. We use Beautiful Soup, which is basically an HTML parser. We can go through the HTML that they use to display the data, and we could create data that's in a format that a program can use. So, structured data for the program to use from display data. It's basically what we do with Beautiful Soup. Playwright, I think I mentioned that before, so that it's a automation web automation framework for Microsoft. It's really nice for doing things like selecting menus, all that kind of stuff. You can automate all of that, so it's great. Bonobo for multi-threading. It's really an ETL framework, but you don't have to necessarily do ETLs with it. You could do some, just extractions. You just use it for a multi-threading framework. It shines at ETLs, though. It's really, really nice for that. HTTP library, we use requests, which is just a standard Python library. Everybody is pretty much familiar with the request, I would imagine. It's really nice for doing REST API calls. And then for sentiment analysis, we use the Natural Language Toolkit. A lot of nice tools in there. We use the sentiment analysis tool is what's being used here, or the sentiment analysis package is being used here. And I'll get into details on how we use that. Okay, so for our classifier, we use the Sentiment Intensity Analyzer. It's a class in the NLTK that we use to look at comments of videos in YouTube or just postings from Reddit. Okay, and then we look at the text in that thing and we determine if that's a positive text or a negative text or neutral, right? So it can be either any one of those things. So what it does as a classifier is it considers a comment positive if it's 0.05 or above, negative if it's negative 0.05 or below, and then neutral if it's anywhere in that range between negative 0.5 and positive 0.5. Okay, so what we do here is that neutral sentiment is it usually is the largest part of any sample of comments that you're going to get, right? So if you leave that in, it tends to dominate, and what you end up with is just all the different sentiments out there that you collect are all end up being about 20%. So you really can't really tell if it's positive or negative. It's just saying 20% positive, 20% positive. Everything is 20% positive. So what we do is we filter out everything in that neutral area, and we only leave the positives and the negatives in there. So and then we do a percentage based on that instead of including the neutral, and it gives you a more true estimate of what's being said in those comments, rather than because the neutral is not really it's not really germane for our purposes. So we filter those out. Okay, another thing we do is we increase our threshold values from 0.005 to 0.1, so we get less false positives that way. So our real range is, instead of this negative 0.05 to positive 0.05, it's really negative 0.1 to positive 0.1, and we consider anything neutral within that range. Anything outside that range is either positive or negative. All right. And also, another thing we do to make our program a little bit more efficient, although it takes a little while still, is so we'll query, say, for Tesla or Pepsi or whatever from YouTube. We'll get back a whole bunch of IDs, like, say, 250 or 1,000 of them or whatever we decide. And then instead of going off and getting every one of those comments based on the ID and then do an analysis on those, which takes a real long time, we randomly sample within that set. So we grab 1,000 and then we randomly sample, say, 50 of those. We grab 50 out of those randomly, and then we do the sentiment analysis on that 50. All right, so that's kind of how we do it. It helps us to be more efficient. You're gonna, anybody using the YouTube public data API, you're gonna want to run into your threshold. You're gonna cross your threshold on the number you could use. So it's really aggravating. So you want to limit that a little and still get a good estimate of what's being said, which is where the randomization comes in. But you don't want to use, you don't want to take a lot of time. You don't want to worry about threshold quotas for queries. So that's what we do. Okay. Don't want to go all the way to that side. We want to give a demo now. So we're going to do a demo. All right, first thing we're going to do is build it. And this just takes a little while, but we're going to build it just to show that, hey, we're building from scratch. This is not, there's no hocus pocus going on here. We're going to build our Docker container. It's got several keys in there, if you notice that. It's got a Polygon key. It's got a Reddit key. It's got a YouTube key. It's got several different ones. It takes a little while to build, so we'll just relax and watch it go. Builds both the Docker containers here. Builds the front end and the back end. Yeah, now we're building the back end. I can see it because I recognize the Python. Playwright does take a little while, so when you add Playwright, it's gonna blow up your build time just a little, because that sucker's, has a lot of headless type of implementations that uses just fairly big code. It's complicated and big, but it works well. All right, now we're down to building the Docker image itself, exporting the image and its layers. Should be wrapping this up fairly soon here. Docker manifest, and we're done. Okay, so we're done building, and we're going to do a Docker compose up. We're going to bring our app up. Alright, we're going to go to where the app is, the Stock Analyzer app. And we're going to hit return, and it shows there. Now, I'll go over this in a second, but there's going to be now on this app, in case you've seen previous versions of this. Now you're going to see a real difference between single-threaded and multi-threaded, because you've got two big hitters in there for the Reddit sentiment analysis and the YouTube that take a long time. So if you go single-threaded, you're going to take a long time to execute. So we're going to go multi-threaded. All right, and then we're going to look at something that we have a chance that there's going to be some negative sentiment involved, because I want to see that. So there's a company called Yelp, and if you've ever dealt with Yelp, you'll understand why there's some negative. If you're a small business, you deal with Yelp. They basically, I think their whole plan of business is to set it up so they hit you a couple times unexpectedly with big bills like $500, $600 that you're not expecting, and it's not obvious that you've actually signed up for that, or so it wouldn't be surprising if it had some negative sentiment. We see it's got positive sentiment. Darn. So let's try again. I want to show you what it's going to look like when we get negative sentiment, and since we're randomly sampling, it could be right on the edge. I'm hoping we get some negative. Yelp. I don't really like Yelp, so I'm hoping it's negative. Let's see. All right, multi-threaded. We're going for Yelp. We're hitting it again. Hopefully we do not. Yeah, here we go. Yes, yeah. Reddit sentiment, 36.6%. Yeah, Yelp. You are. I don't know. I'm not going to say anything bad. I wasn't too happy with Yelp. You get a $500 bill out of the blue, that you didn't even know you signed up for. You get a little upset, and they're like, "Oh, sir, oh my goodness." I didn't really like it. But anyway, that's neither here nor there. And we can see what happens here when we get a less than 50% sentiment. It's going to show you red. Over 50%, it's going to show you green. So Yelp was probably seeded YouTube, I would imagine, because I don't think they're going to get 66% positive from anybody, but that's me. But you can see the parts of the the data that you're going to get. You're going to get its logo. You're going to get its stock ticker, its current stock price. You're going to get sentiment analysis. You're going to get a nice little write-up from ChatGPT based on what the company is. And you're going to get some historical data from Polygon.io. It's going to tell you the monthly closing value for each one of the months going back 12 months. So you can see kind of what it's done. It peaked here in January and another little peak in May, but it's gone down since then to there. So we can see kind of what's going on there. Let's take another one that should be generally positive, and I would say Tesla. Even though it's got some controversy with Tesla lately, generally people like Tesla. So let's see. Let's go out. We're going to be looking. It's going to take a little while because, like I said, it goes down. To get a good reading on the sentiment, I mean, you have to, well, you have to look at some data. You can't just look at 5, right? You have to look at a couple of hundred or whatever, and it just takes a little while. It takes a little while to do that for both of these. All right, so we're going to multi-threaded. We're going to go and we're going to take a look at Tesla, and hopefully it's going to come back. Will you? Won't you? I don't know. Please. Let's see what's going on. Oh, not disabled? No, that's okay. Yeah, finally got Tesla. All right, so Tesla, yeah. Most people are positive about Tesla, right? They're pretty good products. They seem it's a more advanced electric car. People like those. Elon Musk didn't do himself any favors lately because his main, I think his main target audience is not into what his politics are. So maybe that was a little. But generally, people like Teslas, right? So their stock goes up. Their stock is really high if you look at it, 335. And they got generally positive sentiment. It's got its logo. It's got everything there. So it's good. So let's take a look real quick at the difference between single-threaded and multi-threaded just so we can know. Let's go to develop. Let's go to show JavaScript console. I'm using Safari in case you didn't notice. So it may be a little different. So we're going to see, let's say, okay, so our Tesla multi-threaded just took 51,000 milliseconds to complete. So let's try that single-threaded. Oh, it's going to make a fool out of me here. So 51,000 is almost 60 seconds. So it took approximately a minute to complete that query multi-threaded. And we're going to see what it takes single-threaded. And I have a feeling it's going to be over a minute because I think we've been going a minute approximately already. So we're going to see the difference here. Like I said, oh yeah, there we go. So elapsed time single-threaded is 68,000. So yeah, it's not a huge difference, but you can see we got one multi-threaded run in 31,000 and one multi-threaded in 51. So I bet you if we ran it again, the multi-threaded would be somewhere in between there. Let's just try that for the heck of it. Multi-threaded Tesla. It's going to go off. The difference between these two is every piece in the single-threaded, like every piece, meaning getting the logo, doing each one of the sentiments, doing the description, and getting the stock data and making the graph, all these things are done sequentially, one at a time. Boom, boom, boom. You're doing each one of these. You're using a REST API to get each one of these pieces of data sequentially. All right. And then the multi-threaded one is they're all done in parallel. See? Oh yeah, so the multi-threaded, yes. So the multi-threaded is 45 seconds. The single-threaded is approximately 68, right? So there's a significant difference between the two. Yes. And then, so that's how it's done. So the multi-threaded, each one of these, they all get, each one of these pieces of data, it gets started at the same time, and they all run in parallel. And then they all are synchronized and they're returned and then sent back to the app, right? So you should be able to get a pretty nice performance increase by doing multi-threaded. There's a lot of ways of doing that. You could do this totally on the JavaScript side using asynchronous calls. To me, and that's a little more difficult. I try to keep my UI part as simple as possible. That's just me. I know other people have different opinions on that. They do more complicated things on their front end, but I like to keep that as simple as possible so that I can just concentrate on what it looks like in the display in that part, and I don't have to worry about complicated programming in there. I do my complicated programming on the back end. That's just the way I do things. But anyway, that's how it works. Let's see. Yes, let's go back to Google Slides. That's how it works. It was fun to write. Good luck to all of you. I hope you find a good freelancer. And like I said, I'm available anytime. I'm really trying to get going on this, so price is not that important to me. I'm really looking for some work to do for somebody so we can, so we can have a mutually beneficial thing going on, right? So, you got something you need to do, I got some expertise. Let's do it. We'll work on the price is negotiable. We'll work on it. Later on, after I get a couple of gig or bids, I can maybe start charging a little more, but right now, I'm good, man. I want work. I want to be able to do it, and I want to be able to make a customer happy. So that's where I'm at. Hope you enjoyed this, and thank you very much.